The following video will introduce you to ANSYS component in VisualDOC, which allows direct interface to ANSYS Workbench. In this demo, I will solve a simple design optimization problem with analysis performed by ANSYS Workbench Fluent Solver. ANSYS Fluent contains the broad physical modeling capabilities needed to model flow, turbulence, heat transfer for various applications. This is a simple example for demonstration. VisualDOC has a capability to solve extremely complex optimization problems. It is assumed that the user is familiar with the ANSYS workbench. The figure shows a three-dimensional turbulent fluid flow and heat transfer in a mixing elbow. In this elbow, a cold fluid flows into the pipe via large inlet while a warm fluid is injected from the small inlet. The hot flow gets cooled down and the mixed flow comes out of the pipe from the outlet. Here, objective function is to minimize the average outlet temperature. The design variables are inner radius of torus, degree of cylinder position angle theta, and degree of cylinder position beta. Now the first step is parameterization in ANSYS Workbench. Now open the ANSYS Workbench. A Fluent solution has already been set up. As theta and beta cannot be used directly to define the geometry due to modeling procedures, users have to parameterize the variables that are available in ANSYS and pass these parameters to VisualDOC, which will then convert them into synthetic functions of the design variables. To define the geometric parameters, click on Geometry. This will open the Design modular. Click on the torus from Tree Outline panel. Under Details panel, mark the checkbox for inner radius and outer radius. Now click on Cylinder 1. Under the Details panel, mark the checkbox for origin x-axis coordinate and origin y-axis coordinate. Now mark the checkbox for axis x component and axis y component. Next is to define inflow speed in Fluent. Go to Project Schematic window and double-click on Setup. Click on Boundary Conditions. Now click on Parameters below the Zone window. Click on drop-down of Create and select Surface Integrals. Now select the report type as Facet Average. Change the field to Variable Temperature and keep the static temperature as default. In the surface window, choose Pressure Outlet and click Save Output Parameters. I have already saved the output parameter as Tout. Now go to Project Schematic window and double-click on the parameter set. Check whether all required parameters are defined or not. Now open the VisualDOC, create a new project. Now the next step is to create workflow. From component palette, add optimization component. Now add ANSYS component inside the optimization component, as this component is used to define the analysis needed. Add a stop block. Now select the flowchart components in the model tree panel and click on Automatically Connect All Models icon. This would connect all the components based on their order in the model tree. Now click on Automatically Rearrange All Models icon. Now the next step is to set up ANSYS component. Go to Component Editor tab. Select ANSYS component in the Model Tree panel. In the Run Location section, make sure that Analysis Runs Locally radio button is selected. Under Analysis Working Directory, make sure that Use the Model Directory option is selected for the directory part type. Under the Local Analysis Program definition, select Absolute as the file part type. Now click on the file icon and select Executable file for your ANSYS Workbench program, which is located under ANSYS Workbench installation path. For Windows and Linux system, the executable file name for ANSYS program are as shown in the slide. In project file definition, make sure that relative to model directory option is selected, as I have saved the VisualDOC model in the same location where I have saved my ANSYS analysis file. Now click on the file icon and select your ANSYS Workbench analysis file. Push the load data button. Use load data button only when you want to load a new ANSYS Workbench file, or if you have modified the name, the input-output parameters, or the number of parameters defined in the ANSYS Workbench. In Parsed Input Data section, select the input parameters which you want to use in the optimization. Click on the checkbox corresponding to parameters in the Use column. VisualDOC provides a feature to select and deselect all the parameters at once. Now push the test button. VisualDOC will launch the simulation. It is very important to test the ANSYS component to ensure the interaction between ANSYS and VisualDOC. Now the next step is to create data transfer needed for the optimization component. Go to Data Linker tab, select Optimization in the Model Tree panel. Select Optimization in the middle panel. Make sure that Auto Link checkbox is selected. Now click on Automatically Add Data to Selected Model icon. This would add the corresponding links for the data transfer. Next, we will set up the optimization component. Go to Component Editor tab, select Optimization component in the Model Tree panel. In the middle panel, click on the blank row and create two new variables theta and beta which are not defined in the ANSYS Workbench. Deselect the checkbox in the variable column for x0, lx, r2, y0 and ly. Mark the checkbox for variables theta and beta. For datatout, deselect the checkbox in the constraint column and select the checkbox in the objective column. Make sure that minimize option is selected in the goal column. Enter the bounds and initial values for the design variables. Now for the variables x0, lx, r2, y0 and ly, select the synthetic in advanced attribute column, as these parameters are derived from the three design variables. Now right-click on the row of the data R2 and select Edit Dependency Equation. Now enter the dependency equation. I will provide the dependency equations for all synthetic variables in the description section. Similarly, repeat the steps for all synthetic variables. Change the relative finite difference step size to 0.05. Now I will create a simulation monitor to monitor the best objective. Click on the Simulation Monitors tab. Add an optimization history monitor. Click on Expand Hierarchy icon below the Flowchart Components panel as well as List of Monitors panel. Drag the best objective under Simulation Parameters and drop it on the X1 axis of the first monitor. To activate the defined monitor, click on Enable All Monitors icon. Now click on the Validate icon. Our complete model is valid. Now click on the Run icon. To view the defined monitors, click on View Monitors tab in the message area. VisualDOC has the capability to provide real-time updates. As you can see from the graph that the total number of iterations are 3. To view the optimum results, go to Component Editor tab, select the Optimization component in the Model Tree panel. The table displayed in the middle panel has the optimum values in the optimum column. The optimum value for the outlet temperature is 298.79 Kelvin. This completes the demo. I hope that it has helped you to get familiar with the ANSYS component in VisualDOC. If you would like to learn more, I invite you to check other videos about VisualDOC. For more information, please visit our website at www.vrand.com or email us at visualdoc.support@vrand.com. Thanks for watching.